Hello again. In the last unit, you tackled some pretty tough stuff. So I thought we'd do something easy today. Let's learn to count. Ready? 1, 2, 3. Okay, maybe not that easy. Today, we are going to count the number of atoms in this sample of copper, the number of formula units in this sample of salt, and the number of molecules in this sample of water. In order to understand how to count them, you are going to have to meet and understand the mole.
In this lesson, you will define the term mole, calculate molar masses, calculate the number of atoms, molecules, or formula units in a sample when given the mass of the sample, and calculate the mass of a sample when given the number of atoms, molecules, or formula units in the sample.
Oh, I was just trying to see the atoms in our sample of copper, but I'm having trouble. How are we going to count them if we can't see them? We have learned enough chemistry to know that atoms exist, but they're just so darn tiny. Even though atoms can't be seen, they are very real to a chemist. So real that chemists have developed a system for counting atoms. I know that seems pretty bizarre. I mean, the question still remains, how can you count something you can't even see? Let's do a little experiment to try to find out.
The students have been given a cup with 3 dozen grains of rice. They find the mass of the rice to be 0.58 grams. This means that the rice has a mass of 0.19 grams per dozen grains of rice. To check this, the students are now going to find the mass of 6 dozen grains of rice. The mass is 1.24 grams, which gives a mass of 0.21 grams per dozen grains of rice. Allowing for experimental error, the two calculations are the same. Now the students find the mass of a sample of an unknown amount. The mass is 1.94 grams.
So, using the conversion factor that the mass is 0.21 grams per dozen grains of rice, I want you to calculate how many grains of rice are in the sample of rice that has a mass of 1.94 grams. Did you get it? You should have figured out that there are approximately 9 dozen grains of rice in this sample. Remember, when you work a conversion problem, you let the units guide you. So, we put 0.21 grams on bottom and 1 dozen grains of rice on top. We multiply and get 9.2 dozen grains of rice. Let's peek back in on the students to check our answer.
The students are counting the grains of rice in the sample. They have divided the sample into piles with a dozen grains of rice in each. They have 1, 2, 3, 4, 5, 6, 7, 8, 9 dozen, with 2 grains of rice left over.
Excellent. The students were able to use mass to count the number of grains of rice in the sample. They could count the number of grains of rice in this bag without even opening the bag. Are you thinking what I'm thinking? Perhaps we can calculate the number of atoms in our sample of copper, the number of formula units in our sample of salt, and the number of molecules in our sample of water without having to actually see them and count them. Of course we can. Chemists are the smartest of people, after all. And they have come up with a system for counting atoms. Pretty impressive. Think about the experiment our students performed. They didn't try to work with a single grain of rice, because grains of rice are so small. They worked with dozens of grains of rice. And we all know that a dozen is just 12. Since an atom is so much smaller than a grain of rice, trying to work with dozens isn't going to help us here. chemists have come up with a number that is used to help with the counting of very tiny atoms. It is the mole.
A mole is simply a number, a very large number. Sometimes this number is called Avogadro's number in honor of Amedeo Avogadro, who was the first to propose the concept of the mole. A mole is equal to 6.02 times 10 to the 23rd power. Just like a dozen is always equal to 12, a mole is always equal to 6.02 times 10 to the 23rd power.
So, if you have a dozen donut holes, you have 12 donut holes. And if you have a mole of donut holes, you have 6.02 times 10 to the 23rd power donut holes. Now that's a lot of donut holes. In fact, if you covered the surface of the Earth with a mole of donut holes, they would be 5 miles deep. A mole really is a huge number. In fact, it is so large that our brains have trouble comprehending it. So, why talk about a mole? What's the point? Well, the mole is a very important number in the world of chemistry. After all, it is going to give us a way to count atoms that we can't come close to seeing. Let's see how.
To understand counting atoms using the mole, we will compare oxygen and sulfur. First of all, think about this. We know that 1 mole of oxygen atoms is 6.02 times 10 to the 23rd atoms, and 1 mole of sulfur atoms is 6.02 times 10 to the 23rd atoms. So they have the same number of atoms. Would they have the same mass?
We must consult the periodic table for the answer to this question. The atomic mass of sulfur is approximately 32 atomic mass units, and the atomic mass of oxygen is approximately 16 atomic mass units. So, a sulfur atom is twice as heavy as an oxygen atom, and a mole of sulfur atoms would be twice as heavy as a mole of oxygen atoms. That doesn't seem to help us with the counting, but those very smart chemists picked 6.02 times 10 to the 23rd for a good reason. This number of sulfur atoms has a mass of 32 grams, and this number of oxygen atoms has a mass of 16 grams. In fact, you can look at any element on the periodic table, and the atomic mass will tell you the mass in grams for a mole of that element's atoms. Pretty neat, huh? Aren't those chemists something?
The mass of 1 mole of pure substance is known as its molar mass. The molar mass of an element in grams per mole is equal to the atomic mass for that element. The molar mass of a compound is equal to the sum of the molar masses of the elements making up the compound.
Before we use molar mass to count, let's practice finding the molar mass of both elements and compounds. Use your periodic table to find the molar mass of magnesium and chlorine. Easy, huh? The molar mass of magnesium is 24.3 grams per mole, and the molar mass of chlorine is 35.5 grams per mole. Remember, the molar mass is the mass of 1 mole, so the units are grams per mole. Now, let's try something a little harder. What is the molar mass of magnesium chloride? We're going to need to know the formula for magnesium chloride to find the molar mass. Magnesium has a charge of positive 2, and chlorine has a charge of negative 1. We crisscross the charges and get a formula of MgCl2. I told you that it was going to be very important that you mastered formula writing. I wasn't kidding. If you are still having trouble with this, get help. Get help now before you dig yourself a hole that will be very difficult to climb out of. Check with your local teacher for a convenient time to come in and get some extra help. That being said, let's get back to our problem. To find the molar mass of magnesium chloride, we will add up the molar masses of magnesium and chlorine. Except, look at the formula. Each formula unit of magnesium chloride has one magnesium atom and two chlorine atoms. So, we need to multiply the molar mass of chlorine by 2 before we add them. Now we add 24.3 grams per mole plus 71.0 grams per mole equals 95.3 grams per mole. Now it's your turn.
Find the molar mass of aluminum oxide. Now check your work. The formula for aluminum oxide is Al2O3. Its molar mass is 102.0 grams per mole.
I hope you are getting the hang of that. We will continue to practice finding molar masses as we move on to our counting exercises. Remember how we solved the rice problem? We had 1.94 grams of rice, and we knew that there were 0.21 grams in a dozen grains of rice. So we used that as a conversion factor, and we counted the number of grains of rice. We are going to follow that exact same pattern with the molar mass being our conversion factor. The best way to learn this is to jump right in and solve a problem. So here goes. Let's count the number of moles of atoms in 8.0 grams of magnesium. First of all, think way back to Unit 1. We start all conversion problems with a question mark. In this case, we will say, how many moles equals 8.0 grams of magnesium? Well, now we need a conversion fact. Think about what we know. We know that there are 24.3 grams of magnesium in every mole of magnesium. So that'll be our conversion factor. And working the problem, we start with 8.0 grams of magnesium, and we let the units of the conversion factor guide us. So we put 24.3 grams of magnesium on the bottom, and 1 mole of magnesium on the top. Our grams of magnesium cancel. Are we ready to finish it up? Well, look at our question mark and our units. We're looking for moles, and that's what we have left. So we've answered the question that we're asking. All we have left to do is multiply 8.0 times 1 and then divide by 24.3. This gives us 0.33 moles of magnesium. Now, that wasn't too hard. Let's try another one. How many atoms are in 0.7 grams of helium?
Let's begin with how many atoms are in 0.7 grams of helium. The molar mass of helium is 4.0 grams per mole. The units tell us to put the 4.0 grams on bottom and 1 mole on top. The grams cancel. We can't stop yet because we're looking for atoms. The conversion factor we know between moles and atoms is that there are 6.02 times 10 to the 23rd atoms in 1 mole. Again, the units tell us what goes on bottom and what goes on top. The moles cancel, leaving us with atoms. Since that is what we're looking for, we just multiply 0.7 times 1 times 6.02 times 10 to the 23rd and then divide by 4.0 to get 1.1 times 10 to the 23rd atoms.
That's a lot of atoms. Are you starting to get the hang of this counting thing? I told you it was easy. Your local teacher will put up these problems for your class to figure out. Then, we'll try one more variation on this counting thing before we call it quits for the day. Now, don't get confused because you are solving for formula units or molecules. Remember that a mole of anything is equal to 6.02 times 10 to the 23rd. So, a mole of potassium oxide is just equal to 6.02 times 10 to the 23rd formula units of potassium oxide. And a mole of dinitrogen pentoxide is just equal to 6.02 times 10 to the 23rd molecules of dinitrogen pentoxide. Let the units guide you, and you will do just fine. I'll see you back in a bit.
Local teachers, please pause the tape now to allow your class to solve problem set 1.
I hope you're getting the hang of it. We just want to try one more thing. Again, I think the way to go is to jump in and try a problem. Here it is. What would be the mass of a sample containing 5.3 times 10 to the 22nd formula units of calcium iodide? Think about it. This is really just the same thing in reverse. We'll let the units guide us, and it'll be easy. Let's start by writing the formula for calcium iodide. Calcium is in family 2, so it has a charge of positive 2. Iodine is in family 17, so it has a charge of negative 1. Crisscross, and voila. The formula is CaI2. Now, we'll write our problem in question mark format. What mass, measured in grams, is equal to 5.3 times 10 to the 22nd formula units of calcium iodide? Another abbreviation we use is FU in place of formula units. Well, what do we know about formula units? Well, there are 6.02 times 10 to the 23rd formula units in every 1 mole. The formula units cancel. But we're not done yet, since we're looking for grams. We need the relationship between grams and moles. So, we need to find the molar mass of calcium iodide. So going back to the formula and looking on the periodic table, calcium has a mass of 40.1 and iodine has a mass of 126.9. So 40.1 plus 2 times 126.9, because of the formula, gives us 293.9 grams per mole as the molar mass of calcium iodide. So if we're using grams and moles, the units of the problem tell us that 1 mole goes on the bottom and 293.9 grams goes on top. The moles cancel, and we're left with grams on the top. So we're ready to multiply across the top and divide by everything on the bottom.
And this gives us an answer of 26 grams of calcium iodide. Just remember, if you let the units guide you, all these problems are really the same.
Now, it is time to solve our 3 problems for the day. We need to find the number of atoms in our sample of copper, the number of formula units in our sample of salt, and the number of molecules in our sample of water. Of course, we can't count them directly since we can't see them, and even if we could see them, there are too many to count. But if we knew the mass of each sample, I think my students will be able to help us with this.
The students mass the piece of copper and find its mass is 18.46 grams. They tear an empty massing cup, pour in the salt, and find its mass to be 67.69 grams. Finally, they tear another empty massing cup, pour in the water, and find its mass to be 44.99 grams.
Now, your local teacher is going to pause the tape for you to solve the 3 problems of the day, using the data my students collected. Local teachers, please pause the tape for your students to work problems. I hope you solved our 3 mystery problems successfully. You're going to do lots more practice before we move on. For now, it is time for your chemistry quiz.
Cumulative review question number 1 takes us back to ionic formula writing. Which of the following correctly represents the compound formed from the ions Sr2 plus and Se2 minus? A. SrSe, B. Sr2Se2, C. Se2Sr2, D. SeSr.
Cumulative review question number 2. The starting substances in a chemical reaction are called the A. Products, B. Yield, C. Reactants, D. Coefficients.
Number 1. In chemistry class, what do we mean when we refer to a mole? A. A fuzzy little creature, B. A dozen, C. 6.02 times 10 to the 23rd.
Number 2. The periodic table tells you how many grams are in a mole of atoms of any element. This is known as the A. Gram mole, B. Molar mass, C. Atomic mass unit.
You will need a periodic table and a calculator for number 3. What is the molar mass of aluminum chloride? A. 62.5 grams per mole, B. 133.5 grams per mole, C. 116.5 grams per mole.
Keep out your math tools to solve number 4. How many moles of atoms are in 12.0 grams of helium? A. 1, B. 2, C. 3, D. 4.
And finally, another math one for you. How many molecules of water are in 4.8 moles of water? A. 7.97 times 10 to the negative 24th, B. 2.89 times 10 to the 24th, C. 5.20 times 10 to the 25th, D. 1.61 times 10 to the 23rd.
I hope you've had fun counting today. You can impress all of your friends with your newfound knowledge. Right, Mr. Mole? The next time we meet, we will be doing some math that is a bit more complicated. So, be sure to bring your old math hat. Until then, happy counting.